Hello everyone. So in this atomic structure part 2, we will discuss Bohr atomic model and all its formulas, and then after we will discuss a spectrum. In that especially we will study in detail line spectrum, that is hydrogen spectrum. So let's start. So as Rutherford atomic model already told that atom most part is empty, an electron is revolving around the nucleus, but it was not consistent with Maxwell theory. That Maxwell told that if any electron or charged particle moving in the field of other charged particle, then slowly and gradually it will lose energy and falling into nucleus. But here that Bohr atomic model gave certain postulates, and by which Rutherford atomic model got sustenance and it became according to Bohr atomic model. So according to Bohr atomic model, what he told that if electron is rotating around the nucleus, so this extra nuclear path is called a stationary orbit or shell or orbit or energy level. So this all those orbits, their energy is fixed. Means in that if electron is rotating, its also energy is fixed. Means it is not going to lose its energy, means it will not fall into nucleus. Second, he told that quantization of angular momentum, that each electron rotating around the orbit, its angular momentum is integral multiple of this constant h by 2 pi. Means if particular electron is rotating in particular orbit, its angular momentum must be equal to nh by 2 pi. Here this is called quantization of angular momentum. N value will be 1, 2, 3, 4, is not 1.65, and fractional value not possible. Next after that, if electron is there in that its particular orbit, in its native orbit, so it will neither lose electron, neither it will lose energy, or neither it will gain energy. If it is not losing and not gaining energy, means it will be still there in its own orbit and it will not fall into nucleus. If electron going from its own orbit to higher orbit, means we need to provide energy, so it will go from its state to higher excited state. And if electron is going to lower orbits, means it will lose its energy and then it will go to lower orbits. Another is that since this electron in this particular its own orbit, so it will not fall into nucleus, means force also will be balanced. Coulombic force is equal to centrifugal force. So kq1 q2 by r square is equal to mv square by r. By this two equation, quantization of angular momentum and force balance equation, he derived all those formulas for electron. So remember here one thing, that not one thing, two things, that in Bohr atomic model, all Bohr atomic model results that all derivations is based on one electron system, based for one electron system only. Either it is for hydrogen or hydrogen like system like He plus, Li plus 2, so on and so forth. And another thing is that Bohr's consider electron as a particle, means it is more having particle nature as he considered, and wave nature he not considered. That's why electron is moving in a stationary definite path. If it is considered as a wave, then it will move in different path. Are you understanding? It will move like a wave. It will not move like a circular path. So these two things, that it is valid for one electron system. Second, he considered electron as a particle nature. So on behalf of that, radius, by equating both centrifuge, that force balance equation, and quantization of angular momentum, by equating and calculating that radius formula, we got r is equal to 0.529 n square by z, where radius directly proportional to n square, inversely proportional to z, and it is there in angstrom. If one electron system, if radius we are calculating, so it will be ratio will be r1 by r2 is equal to n1 square divided by n2 square, because they are directly proportional, into z2 by z1. Similarly, velocity of electron, you can see when electron revolving around the nucleus, so it is 2.18 into 10 to the power 6 into z by n meter per second. To one electron system, that electron's velocity ratio will be z1 by z2 into n2 by n1. Here some related to that graph, that radius versus n. If it is n square, then it will be a straight line. If it is radius versus n, parabolically increasing graph. Radius inversely proportional to z, so it will be hyperbolically decreasing graph. Radius versus 1 by z, so it will be y is equal to mx, a straight line. In that, hydrogen atomic number is less, so it 1 by z value will be more. So if we are multiplying by 1 by z higher value, so radius will be more. So radius is more for which one? That lighter atomic, or that which atom, one electron system which having less atomic number, and helium having atomic number more. So its graph will be a straight line passing from origin, but it will be below hydrogen. Next, velocity versus n. So velocity and n is inversely proportional, so hyperbolically decreasing curve. Velocity versus 1 by n. So velocity versus 1 by n graph, you can see it is directly proportional, y is equal to mx, passing from origin, increasing linearly. Velocity versus z, again it is passing from origin and increasing linearly. Now we will calculate time period for that revolving electron around the nucleus in one electron system. So time period, time is what? Total distance divided by velocity. So total circumference is 2 pi r divided by v. So keeping here normal, that general formula of radius, that is n square h square divided by 2 4 pi m k z e square. Similarly for velocity also, so we'll get time period overall by neglecting all those constants and all. Time period directly proportional to nq divided by z square. N is number of orbit, z is the atomic number. Similarly, frequency is reciprocal of time period, so it will be z square by nq. Acceleration of electron, velocity by time, so it will be zq by n4. Z is again atomic number, n is number of orbits. Now we will calculate total energy of electron. So total energy of electron is potential energy plus kinetic energy. So total energy, potential energy, here you can see k q1 q2 by r. So since that electron is revolving around the nucleus having proton, and electron is negative, so it having attraction. So whenever attraction between charge species, then potential energy will be negative, and both charge particles having same nature, then potential energy will be positive. Means negative and positive sign just representing attraction or repulsion between that charge particle while calculating potential energy. So here you can see minus k q1. Q1 will be what? That whatever atom is there, so z into p. P having also same charge as electron, so z into e, that in nucleus proton having charge, and electron which revolving around, it is e. So total minus k z e square by r. This is the potential energy. Now to calculate kinetic energy, we know force balance equation. Coulombic force mv square by r is equal to k q1 q2 by r square. So again k is constant, q1 will be z into e, q2 is electron, so k z e square divided by r. So from here r cancelled, so it became mv square is equal to k z e square by r. mv square again dividing by 2, so it became k z e square divided by 2r. Clear? So this is your kinetic energy, that kinetic energy of that electron. So total energy is equal to kinetic energy plus potential energy. So kinetic energy is k z e square by 2r, and potential energy minus k z e square by r. So total energy came minus k z e square by 2r. So total energy is minus kZe square by 2r, whereas kinetic energy is kZe square by 2r. means total energy is just negative value of kinetic energy, and total energy is minus kJd square divided by 2r, and potential energy is kJd square by r, means dividing by 2 is the total energy. So potential energy dividing by 2 is the total energy. This relation is very useful. Now total energy as we calculated minus kJd square by 2r. So keeping r value, general formula again, n square h square divided by 4 pi mkJd square. Keeping all those constant value and calculating, we will get energy, total energy of that electron in one electron system when it is revolving around the nucleus, minus 13.6 Z square divided by n square electron volt per atom. So this is the total energy revolving of one electron system, whatever hydrogen or helium plus its atomic number here, and this is the number of orbit. So this is the total formula, minus 13.6 Z square divided by n square electron volt per atom. If we will take two energy ratio, so it will be E1 by E2 is equal to Z1 by Z2 square into N2 by N1 square. Next, since total energy, kinetic energy, we discuss kJd square by 2r. So kinetic energy inversely proportional to r, means by increasing r, kinetic energy will decrease. Means by increasing radius, kinetic energy will decrease. But by increasing r, since here it is negative, so potential energy will increase. Similarly, by increasing r, overall this value will decrease, means it is less negative, so total energy also will increase. So from here, by increasing r, total energy is increasing, means here you can see potential energy by increasing r, it is also increasing, and kinetic energy is decreasing. So this is the relation between that total energy, potential energy, and kinetic energy with respect to r. R is the radius of the orbit. Now at infinity means as we are moving, n value if will increase. So by increasing n, overall this value will decrease, and this will be, since less negative, so total energy increasing. So since it is negative, so maximum it will reach till 0. So at infinity, potential energy is 0. At infinity, potential energy will be 0. Why? Because at infinite distance, no interaction between electron and nucleus. So potential energy will be 0. At infinite, since n value we are increasing, so total energy is increasing and it will reach to 0. So since total energy is 0, so kinetic energy also will be 0. So at infinite, both energy will be 0, means electron will be free from nucleus. This negative sign is only representing attraction between electron and nucleus. Now here we will discuss that graph, that total energy is negative of Z square, means this is decreasing that parabolically down. But total energy is equal to minus of kinetic energy, means kinetic energy will be 13.6 Z square. So this is parabola equation, so it will increase parabolically, correct? So this graph also important. Now we will discuss some of the limitations of that Bohr atomic model. So he could not explain Zeeman and Stark effect, that when line is passing through electric and magnetic field, so it will split, that one line will split into 2-3 wavelength of line. So in Zeeman effect, in presence of magnetic field, if line is splitting, is called Zeeman effect, and in presence of electric field, if it is splitting, is called a Stark effect. So this phenomena was not explained by Bohr atomic model. He could not explain line spectrum. He not gave proof for quantization of angular momentum, that mvr is equal to nh by 2 pi. This his Bohr atomic model, since it is he considering electron as a particle, so is not consistent with de Broglie hypothesis and Heisenberg uncertainty. De Broglie hypothesis and Heisenberg uncertainty, both they considered electron as a wave, means it having more of a wave nature, less of particle nature. Hence, it is not consistent with both of the theory. It is only valid for one electron system. Clear? Now, when we are calculating energy, so let's suppose if electron is going from lower orbit to higher orbit, means energy is absorbed. So if energy is absorbed, so for endothermic, change in energy will be positive. And if an electron is coming from higher orbit to lower orbit, means energy will release, means that time total energy will be negative. Clear? So since let's suppose here value wise same, let's suppose for example that electron is coming from infinity, electron is coming from that infinite orbit to ground state. So when it is coming from infinity to ground state, what will happen? It will release energy. So that energy difference will be what? E2 minus E1. So E2 is what? Minus 13.6. E2 minus E1. So E2 is that this one 0 minus 13.6. So minus minus plus. So overall energy will be, sorry, E2 minus E1. So E2 will be what? E2 will be this one minus 13.6 minus 0 volt. So overall energy will be minus 13.6 electron volt. This is exothermic. And if electron is going from lower orbit to higher orbit, means it is absorbing energy. Means final energy is 0 minus 13.6. So overall it will be minus minus plus 13.6 electron volt. So numerical value will be same. Only thing is that sign will be different. If it is positive, means it is endothermic, electron is going from lower to higher. And if it is negative, means electron is coming from higher to lower states. Clear? So that same, that formula we applied. So change in energy is equal to, if here it is positive, means it is endo, means energy is absorbed, means electron is moving from lower to higher. So here you can see 13.6 into 1 by n1 square minus 1 by n2 square electron volt per atom. Or we can also write in joule. So in joule, this constant value, keep that in your mind, 2.18 into 10 to the power minus 18 into 1 by n1 square minus 1 by n2 square joule per atom. So this is the total energy, change in energy. Only you that keep that in your mind, sign convention. If it is coming down, so energy will release from n2 to n1. If it is going from n1 to n2, so energy will be absorbed. Okay. Now here one thing, that let's suppose if it is asking maximum energy or maximum frequency, energy and frequency are proportional, so wavelength will be minimum. So if it is asking like that, so energy will be maximum when N2 will be large and N1 will be minimum. Then only energy value. Plus and minus again is representing endo exo value I am asking. So value will be what? When N1 is the lowest and N2 is the highest. So when it is coming from highest to lowest, then energy will be maximum, frequency will be maximum, wavelength will be minimum. If opposite of that, if they are asking energy and frequency minimum and wavelength maximum, so always remember whatsoever n1 n2 set of value given, in that n1 value you take highest one, and then after n2 will be just next of that preceding value, means n1 plus 1. That's it. This is the trick by which you will get the highest wavelength. Now we will discuss some terms. Like first is ionization energy. So ionization energy in one electron system, that minimum energy is given that when electron moving from its ground state to excited state, means infinity. So at that moment, that whatever minimum energy we provided to isolated gaseous atom is called its ionization energy. So ionization energy delta E, ionization energy is equal to delta E is equal to, since it is endothermic, So overall it will be plus 13.6 Z square into electron volt per atom. Ionization potential is also magnitude wise same. Ionization potential value is also same like ionization energy for that respective value. Only unit will be different. If it is in electron volt, so it will be in volt. To ionization energy ratio will be what? Z1 divided by Z12 squares. Clear? Next we will discuss excitation energy. So excitation energy is what? That when any electron from ground state to excited to any other excited state, ground state to any other excited state, not at infinity, otherwise it will be ionization energy. So excitation energy is again minus 13.6 Z square, N1 value is 1 minus N2 square electron volt. So here also excitation energy and excitation potential value numerically it will be same, only its unit will be electron volt whereas its unit will be volt. Now third we will discuss binding or separation energy. According to its definition, what? Minimum energy is given to isolated gaseous atom when that electrons from any state, ground state or 1 to 3 is sent to infinite. So suppose from ground to infinite as we sent, so binding energy will be ionization energy. Otherwise if we are sending electron from any other excited state to infinity, then that binding energy is not ionization energy. So total energy change is equal to binding energy is 13.6 Z square divided by N1 square minus 1 by N2 square is infinite, so became 0, and unit is electron volt per atom. Clear? On behalf of this we will discuss one question. Like suppose for example here that first excitation potential of hydrogen is given 15 volt, asking ionization and second excitation potential. So since here it is given first excitation potential 15 volt, so excitation potential to excitation energy, just unit I will change, 15 electron volt. Excitation energy, first excitation energy means electron excited from ground to second, means first excited state. So 15 electron volt is equal to 13.6 Z square, keeping N1 N2 value. You know this 13.6 into Z square is only ionization energy. So ionization energy value came 20 electron volt. Now from here we will calculate second excitation energy. So for second excitation energy, sending electron from ground state to second excited state means second excited state N value will be 3. So here that again delta is equal to 13.6 Z square 1 by N1 square minus 1 by N2 square. So 13.6 Z square ionization value, ionization energy is 20. So overall it is coming second excitation energy 160 by 9 electron volt. So second excitation potential will be what? 160 by 9 volt only. Now coming to a spectrum topic. So a spectrum also will discuss mainly for hydrogen atom, means one electron system only. What is meaning of a spectrum? A spectrum is that when white light or any light is passing through that prism, that emitted light, as it is passing through prism, so whatever that according to that wavelength it segregated due to that prism, and it is formed on photographic film or a spectrogram, that is only called a spectrum. So here on behalf of that, based on nature and based on origin, based on nature, two types of a spectrum is there. One is continuous and another one is discontinuous. One is continuous, another one is discontinuous. Discontinuous is two type, band and line, and on the basis of origin, absorption and emission spectrums are there. So emission classified on behalf of this continuous and discrete. Similarly absorption also we can classify. So here you can see that emission spectra in that continuous spectrum. A spectrum plural is called a spectra. So when white light having infinite frequency means infinite wavelength of the range. But generally we will consider here that as white light passing through prism, so we'll cover only that fundamental colors behavior. So when white light passing through prism, so it's segregated on behavior, that violet, indigo, blue, green, yellow and orange and red. So why it is called continuous spectrum? Since violet last wavelength means last line as it is completed, that time only indigo started, means there is no gap between violet and indigo, that color or that wavelength or that frequency, hence it is called continuous spectra. Next after that, discrete spectra is what? In that in that what will happen, that suppose for example if molecule is there, so molecule we given energy by energy of photon, so by given energy of photon molecule became excited. An excited molecule is unstable, again it want to come to ground state, so while coming, so it will release energy, and that energy when it is passing through prism, then that whatever spectrum is formed is called band spectrum. So you know, according to Planck, what he told, any molecule will not release energy at a certain edge of sudden, all energy it will not release. So if it is releasing bit by bit, so what will happen? First bright sprint will come, then again dark, again bright, again dark, and so on and so forth. Similarly, if atom is there, so if atom is excited, again it is coming down, so it releases energy, and that energy is passing through prism, so it will form lines, not like band, it will form lines, then again dark, again line, again dark, again line. So such type of spectrums are called line spectrum or atomic spectrum, and that only we will study in detail, hydrogen spectrum. Here one important illustrations we will discuss. See here in this, if any atom is excited, so after excitation what will happen? It will release energy so that it will go to ground state. So after absorbing, if it is in excited state, so now it is releasing, so let's suppose it releases lambda 2, lambda 4 and lambda 6. So this is lambda 2, lambda 4 and lambda 6. So these are the color lines, and in between this is the dark space, dark space, dark space and dark space. Clear? So this is one type of spectrum which is from excited state, that energy is coming out, so according to that different wavelength is formed. This is called emission line spectrum. Now after emitting, now hydrogen came to ground state, it became stable. Now if white light we are passing, so again it will go to excited state, means it will absorb which wavelength? Lambda 2, lambda 4 and lambda 6. Remaining lambda 1 in Vibgyor, all remaining 4 wavelengths are there. So lambda 1, lambda 3, lambda 5 and lambda 7 will come out from the sample. So these are the, so here it is, you can see lambda 1, lambda 3, lambda 5 and lambda 7. What are the absorbed lines? Lambda 2, lambda 4 and lambda 5. So you can see this is called absorption line spectrum. Clear? Now in this both photographic film or this spectrogram, you can see very clearly they both are negative of each other. Why? Because here if it is dark, here it is color. Here it is this light is there, here it is dark line is there. Correct? Here color, here it is dark, here it is color. So this both are negative of each other, and this is very nice illustrations for line spectrum. It will continuously, it will happen. Hence means it will form first, then after this, then after this, then after this, so on and so forth. Next, moving further, now we will discuss absorption spectra. So absorption spectra is what? When that white light is passing through particular solution, so particular solution having characteristics that it will absorb certain wavelength. So from white light, let's suppose NaCl absorb LO wavelength. So remaining all 6 wavelength will come, but in between LO will having dark spot because already it is missing, it is absorbed by NaCl solution. If you will keep here copper sulfate solution, so it will absorb blue color. So according to that, this type of spectrum is called absorption spectrum. Now coming to line spectrum or hydrogen like atoms which is forming line spectrum. In that emission spectrum, emission means what? Once hydrogen gas is there, so hydrogen gas excited, now as it is coming down in ground state or its respective orbit, then it is releasing energy and that energy is passing through prism, so it will form different set of line spectrum. Clear? So let's suppose here, let's suppose that as electron coming from excited state to ground state, so that energy only passing through prism and line spectrum is formed. So here we are taking magnitude, that when it is coming from N2 to N1, so N2 energy is minus 13.6 Z square, minus 13.6 Z square by N2 square minus 13.6 Z square by N1 square, means higher energy minus lower energy, just taking magnitude. So total delta E magnitude will be, otherwise it will be negative since it is coming down, so energy releases. So delta E is also value of one energy, so that energy is Hc by lambda, Hc by lambda, so is equal to 13.6 Z square into 1 by N1 square minus 1 by N2 square. Clear? So this is the magnitude of energy when electron is coming from excited state to ground state. In that, this is the formula. Now from here can we write one thing, that 1 by lambda is equal to this wave number, and it is equal to 13.6 divided by Hc into Z square, 1 by N1 square minus 1 by N2 square. 13.6 divided by Hc is R, one another constant. This constant is called Rydberg constant, into Z square and into 1 by N1 square minus 1 by N2 square. So Rydberg constant value, very important, sometime questions they are asking with this. So Rydberg constant is what? 13.6 divided by Hc electron volt, or we can also write RHc is equal to 13.6 electron volt, or 2.18 into 10 to the power minus 18 joule. Clear? So in questions or numerical, if it is required, utilize it properly. Rydberg constant, another also value, that 1.1 into 10 to the power 7 per meter. Now, as that excited atom releasing its energy and passing through prism, different set of line spectrum is formed. So first that line spectrum set is Lyman series, second one is Balmer series, third one is Pascal series, fourth one is bracket series, next one is P-Fund series, after that Humphrey also there. So here you can see that when electron is passing from any excited state to ground state, n is equal to 1, then such type of all series are called Lyman series. If electron passing from any excited state to n is equal to 2, then it is called Balmer series. If any all excited electrons in one electron system passing from excited state to n is equal to 3 is called Pascal series, and so forth. If electron is coming to fourth, all from excited state, is called bracket. If electrons all are coming from excited state to n is equal to 5, P-Fund, and similarly Humphrey also. See here that since electron is coming from second orbit to first orbit, ground state, so here energy difference is here we can say that as electron is coming from higher to lower, means maximum to, so here can I say that energy difference is maximum? Yes, so here energy difference is maximum, and this will be this side. So here energy will be maximum and wavelength will be minimum, and this side wavelength will be minimum. One second. And this side, since here energy difference is minimum, wavelength will be maximum. So this line, when it is coming from 2 to 1, is called first line, is also called alpha line. When it is coming from 3 to 1, it is called beta line. If it is coming from 4 to 1, it is called gamma line. So like that, alpha, beta, theta, like that they will ask. Clear? And the last line is called series limit, marginal line, or last line. So this last line having, you can see, energy is maximum, wavelength is minimum, and here energy is minimum, wavelength is maximum, first line. They will ask also shortest line. Shortest line means, don't think by just length. Shortest length means they are asking shortest wavelength. So shortest wavelength, which one having? When it is coming from infinity to ground state. Similarly, this same concept we can apply for remaining all those series. Clear? Marginal line or series limit or last line means what? When n1 is equal to 1 and n2 is equal to infinity for Lyman series. Similarly, marginal line, last line or series limit for Balmer will be what? When n1 is equal to 2 and n2 is equal to infinity. So and so forth. Same concept will apply for other series also. So now here you can see Lyman series. In that ground state, all electrons are coming and is coming from n2, n3, n4. Clear? So n2 is, you know that if electron is coming from 2 to 1, so 2 is called first excited state, 3 is called second excited state. This all those lines that their wavelength is in the UV region, ultraviolet region. First line is called alpha line when it is coming from 2 to 1. Second line or beta line when it is moving from 3 to 1. Last line or marginal line or series limit is what? When it is coming from infinity to ground state. So for that, n1 will be 1, n2 will be infinity. So for that, wave number is equal to 1 by lambda, Rydberg constant for hydrogen, atomic number is 1 by n1 square, n1 is 1 by n2 is infinity. So wavelength for last line is 1 by RH. So like that we can calculate for any other series also, last line wavelength, marginal line or series limit. This first and second, this first line and this last line is called that extreme lines. Okay. So moving further, now we are calculating energy difference of the Lyman series. So Lyman series energy difference is how much? Here you can see total difference is 10.2 electron volt, and here from infinite to ground state 13.6. So maximum energy is 13.6 electron volt, minimum is 10.2 electron volt. This is the range. So wavelength will be what? Opposite of the energy. So you know that 10400 divided by, if we will do minimum energy, that will be maximum wavelength, and 12400 divided by maximum energy will be minimum wavelength. So this is the range of wavelengths of Lyman series in angstrom. Extreme lines means first and last lines are called extreme lines. Clear? Next, coming to Balmer series. So in Balmer series, remember only 4 lines are in visible region. Remaining all lines means remaining first 4 lines means this is the first line, this is the first line when it is coming from 3 to 2, 4 to 2, 5 to 2, like that. So that first 4 lines are only in visible region. After that, remaining all those lines are in infrared region. Here n1 will be 2, n3 will be 3, 4, 5 to infinity. Similarly here also energy difference we can calculate. So maximum energy difference from infinity to n2, that will be 3.4, and minimum energy difference n3 to when electron coming from n is equal to 3 to n is equal to 2, that will be 1.9 electron volt. And similarly wavelength range also we can calculate. 12400 divided by minimum energy is the maximum wavelength range, divided by 3.5 is the minimum wavelength range in angstrom. Similarly dear student, you can see here Pascal series. So Pascal series, all line spectrums are in infrared region. Their wavelengths are similar to infrared region. N1 is equal to 3, N2 will be 4, 5, 6 whatsoever. Similarly, here bracket series, so all its wavelengths are in infrared region, and N1 is equal to 4, N2 will be 5, 6, so forth. Similarly, P fund is also infrared. N1 value is 5, N2 will be 6 and 7. And last one is Humphrey series. This is also in infrared region. N1 value is 6, N2 value will be 7 and 8. Okay. Now we will calculate number of photons, means as electron coming from excited state to ground state is releasing energy. That releasing energy also in form of h nu only. So number of photons emitted by sample of hydrogen. So when one electron in any excited state to coming to ground state, then total number of photons will be different photon. Different photon means when it is coming from, let's suppose 2 to 1, or if it is coming from 3 to 1 or 2 to 3, those are different types of photons or different types of line spectrum. So here in math nc2, so that formula only, that n into n minus 1 divided by 2. What is the n? When it is coming from any higher excited state to ground state. Next, number of photons or number of line spectrum, all possible when that electron is passing from excited state n2 to any other excited state n1, is not coming to ground state. Then it will be total delta n into delta n plus 1 divided by 2. Delta n is what? N2 minus n1, that higher excited state to lower excited state value. In case of isolated atom, single isolated atom, if it is having only one electron which is making transition, this is little bit exceptional case, only valid for like helium plus and all. So in case of single isolated atom, if electron make transition from nth to ground state, that maximum number of spectral line observed is n minus 1. So we'll do some questions. Now here you can see, if electron make transition from 7th excited state, means n1 value is 7 plus 1, 8. And to second state, means n value is here 2. So delta n is what? N2 minus n1, 8 minus 2, it is 6. Okay. So find the maximum number of spectral line. 6 into 6 plus 1 divided by 2, 21. Next question, that in hydrogen sample ions are in particular excited state, if electron make transition to first excited state and produces 15 different spectral line spectrum, then calculate where that electron was. So here you can see, again we will apply this formula, is equal to 15. So simple quadratic equation, x value should not be negative because energy level n1 n2 will be not negative. So n value is here is coming 1 minus 6 and 1 is coming plus 5. So n minus 2, since here we consider this one x, so x is what? N2 minus, like that first excited state. So first excited state means n1 is 2. So n minus 2 means n1 minus n2 is equal to 5. So n is equal to 7. Clear? Next one, last concept here we will discuss, that is equitransition. What is that equitransition? So equi energy transition, that if suppose electron is moving from higher excited state to lower state, and if their atomic number is same, so if they are moving from N2 to N1 and another electrons are moving from N3 to N4 to N3, since these energy levels are different, so will not equate what their energy difference. Delta E1 is equal to delta E2. But yes, same, if suppose one electron system Z1 and Z2 is there, and in that Z1, if electrons are making transition from N2 to N1, and for Z2 electrons are making transition to N4 to N3, there might be possible that energy will be equal. In same atom it is not possible. So when it is equal, so we'll equate this one. So this is only possible. 13.6 13.6 cancelled. Z1 by Z1 square into N1 square should be equal to Z2 square divided by N3 square, and Z1 square divided by N2 square must be equal to Z2 square divided by N4 square. Then only we can equate their energy and we can solve questions. So here we completely completed that all those spectrums and all concept. Next class we will discuss in part 3 that furthermore from here. So till here we discussed that Bohr atomic model, all those formula, radius formula, energy formula, velocity formula, total energy, potential energy, kinetic energy relation, all those graphs, and then after further we moved on. Then after we discuss all types of a spectrum, we discuss one very important illustration also, that line spectrum, in that absorption and emission line spectrums are negative of each other. So next part 3 we will discuss furthermore. Thank you very much.